Our speaker this evening was formerly the CIO of Serverstall, managing over $15 million of annual IT budget, and he's got over 18 years of experience. Please welcome our very impressive co-founder and CTO of GuardHat, Anupam Sengupta.
Thank you. Thank you. Thank you. Thanks for having me. By the way, it was actually Severstal, slight correction. Severstal. Severstal means northern steel in Russian. And I'm actually based out of Detroit, so it means northern steel, Russian steel. So we are actually based out of Detroit. I live in Detroit, or at least the metropolitan area. Severstal till 2014 used to own the fourth largest steel manufacturing complex in the US, which was and still is known as the Ford Rouge Steel Plant. So basically Henry Ford actually built up this plant in 1923 when he was building the integrated Model 3 factories. So as part of that, he was building his own steel, and that plant is still operational today. So I had the privilege of being the CIO there for a short while. So I didn't want to correct you, but just wanted to give you the context of the story. So what are we going to talk about today? I mean, I'm sure you have seen the description and the invite, but I just wanted to set some expectations and also tell you about what I have here. We can certainly talk about more things that are not there in the presentation. But I'm essentially coming here today as an end user of the HPCC Big Data platform. I'm not part of HPCC. I have my own startup, which is based out of Detroit. We started it in 2014. It's called GuardHat. We are manufacturing an industrial IoT safety device, which we are planning to deploy pretty shortly. So it is going to become commercialized by end of this year. It's already in pilots and in field trials. And today's presentation is really about our experience as a IoT product manufacturer and using HPCC as a backend system for our big data analytics. We believe it's a little unique because we are applying certain paradigms which may not apply in a normal situation when you think about big data, especially when you are connecting physical devices in a real world to a backend system. The mechanics, the data flows, the data streaming, the connectivity, there are a lot of things which you probably either don't have to worry about or change quite a bit. So maybe we can share some ideas about that. But again, to level set, I'm an end user just like you. I'm by no means trying to say that HPCC is the latest, greatest. I hope you would take that away, but it's really about sharing some experiences and thoughts, as well as our implementation out here. Is that good? Okay. Make sense? Right, so we'll get started as soon as I get my presentation up.
So it's not latest and greatest, right? You said it was not latest and greatest.
It is pretty close to being there, and I'll talk about what would be the latest and greatest towards the end of this. All right, so first of all, it's getting cut off a little bit, so I don't know why. So let's go right to the product. So I just wanted to set some context around what is the product we are talking about, because the name of the company probably gives you a clue, but it's a smart wearable device. It's a smart hard hat. It's an industrial hard hat. And the smartness actually comes from a lot of factors. The device actually has a bunch of sensors. It is a telephony device. It actually can do audio-visual telephony for the end wearer. It measures the contextual environment that the worker is operating in. It measures biometrics. It looks at the environment. Based on a lot of data, it does local processing on the device itself for most of the data that it is actually collecting on a real-time basis. It also sends out this data back to the backend software through a pretty substantial infrastructure that connects the device to the backend or to the analytics software. We have a couple of patents on it. We have built the prototype, so the pictures you're seeing are not CAD. These are actual real pictures of the device itself. And as I said, we are going to make it commercialized by end of this year. We already have a few pilots in the pipeline with some of the majors in the US and Europe. And our hope is that by middle of next year, you'll see a lot more about this. But we're not going to talk about my product today. Just think of this as a dumb IoT device. It's a package of sensors that is collecting a variety of data from the real world, as well as the person that is wearing this on a live basis, on a real live streaming basis. Just to give you a sense of the data volume here, excluding the telephony and the media, which is essentially audio video, which itself is a huge chunk of the data. Just pure sensor data alone, for an 8-hour shift, this device generates close to 20 megabytes of data. And it is a wireless device, so you can imagine the consumption rates. A median deployment site where something like this would be deployed would have about 100 to 300 workers wearing this. So just do the straight math, and you start to see the volume of data coming up. And this one shift. There are 3 shifts normally in industrial, even in the US. So you multiply it by 3. So numbers start small. All right. So we already talked about this. A couple of other things that this does, we will not talk about it, but you may want to keep it in your mind because it influences some of the decisions. Is that it is a full-fledged SIP-based telephony stack as well. It is a VoIP telephone endpoint. So if you have a VoIP telephony infrastructure, it connects to that. And you can talk through that. So telephony also comes into the last mile data connectivity. Just to give you some context as to why did we come up with this crazy idea of putting sensors in a hard hat. As I said, I used to work in Severstal, as did a few of my other co-founders of the company. And we ourselves were operators. We had about 3,000 workers working for us across the US. We had about 4 plants, including the Detroit one. And based on the safety profile of what was happening on the ground as well as what is happening even today, not just in steel but across the industry, we were looking for a device which could give us the last mile connectivity and give us contextual awareness of the worker and his or her safety conditions at that point of time. A couple of data points probably don't make sense unless you actually see someone falling down and you have to actually handle that. Every year, on a pretty steady state basis, in the US alone, about 4,000 lives are lost on the job in an industrial context, whether it's steel, whether it's auto, whether it's logging, railways, you get to see the news, Amtrak and things like that, but there are quite a few other places. This has been consistent for the last 6 or 7 years or so. And this is actually very shocking because if you think about the focus that is on safety, right? In an industrial context as well as in your normal lives, this shouldn't happen. We should be losing 4,000 people. That doesn't even come in the news. Every year. This translates to, today, 30 people die. Every day, 30 people on an average are dying because of industrial safety issues. And that's actually fatalities, right? There are severe incidents, someone loses a limb, someone's back is broken, someone can't do, someone has a severe injury. 3 million plus every year. Do the daily math. Just do the daily math. These are crazy statistics. You think about this and you then worry about why are people not applying technology to solve some of these problems. We can't make it 0, but can we make 4,000 as to 3,000? Right? 3 million to be 2.5 million. If you look at some other safety aspects, and we are just using helmets, but we have actually studied quite a few other things. If you look at the motorcycle helmet, as a very simple example, or NFL helmets. Everyone knows about the movie Concussion, right? It came out and it's about head injuries. There are actually smarter helmets coming out which will resolve that. We have seen that, it's already in the market. There are other equipment which is coming for kids, for bikes, for a lot of other things that is actually expanding quite a bit. This slide is actually cut off, but this actually shows the progression of these devices. If you map a hard hat or an industrial worker's safety equipment from 1960 to whatever you can buy to right now, if you go out and buy it from Home Depot, the design, the technology has not changed. It really hasn't changed. The only thing which has changed is helmets used to be built out of steel. Now they are built out of high-density polyethylene. That's the only thing, and that's a commercial decision. It doesn't change the mechanical properties of the hat. Anyway, long story short. When we, in 2014, we decided that we could probably do something about it, the co-founders and myself. And we sketched out this idea, and 2 years later, as I said, we have a prototype, we have a pipeline, we have end customers, get this into the market. What does it do? As I said, it's a bunch of sensors. That's the easiest way of thinking about it. And just to generalize IoT a little bit, IoT is a buzzword, right? It means a lot of things. It's like big data, it's like SOA, it's like the cloud. So the perspective that you bring in probably defines what it actually means. For us, IoT really means a connected end device that gets us data, contextual data for the user who is using this actual device, who is wearing the hat. So based on the data that we get, we actually do a lot of real-time analytics and try to detect events. Is something going to happen? Has something actually happened? If something has actually happened, how do you react to it? So it's primarily a preventive device, but you can't prevent everything. So we try to also look at the mitigative aspect of incidents. If something does happen, the biggest cause of things getting worse is not getting help in time, as a very simple example. So we try to get help in time. In certain cases, you have to take certain other actions. For example, fire alarms, as you know, everywhere. So just 3 examples here. We look at lockout violations. Lockout is an industrial term that you use for essentially what is geofences. So think of it as geofences. We look at falls, we look at toxic gases, look at about 42 different conditions. These are just examples. But just to get your idea around how the sensor data is tied to some meaningful action that the system can take. What the system actually is, and this is where we'll start to get into the data side of things, which is I think why all of you are here today. But that story was essential because you need to connect that back to the back end. So we have the devices. The system actually is a simple 3-part system. We have the IoT devices, in this case for us the hats. They are collecting real-time data from the sensors. They have a bunch of other things which are not material for today's conversation. We have a middle platform, which is a combination of infrastructure that does the connectivity, actually connects the hats, gets the data, does the telemetry, etc. And also our analytics and inference engine. So we use data from not only one device, but the collection of devices to detect events. A simple example would be a gas emission, okay, which is one of the core causes of injuries. Again, carbon monoxide, there are other gases. It's not sufficient for a system to just measure one data point and say there is a gas emission. You have to look at the trends. Gas emissions are also tied to geolocations. So you have to see the spread of the gas. If it's starting here, then how does it spread? And does it become really toxic for your actions? So for those situations, we are using the analytics engine, both for point-in-time data as well as looking at the aggregate data over history as well as over geolocations. And finally, based on that, the first application that we have built is safety, which is what I'm talking about. But there are other applications that we are also building. So this is actually an ecosystem play that we are trying to get. I'll actually stop here for a bit because I did a little bit of information dump. I think I went through 5 slides very quickly. I wanted to show those slides because that sets the context for what is to follow. And this is where I hope your interest levels will start to come up. Because this is where the data pipeline starts from. This is a pictorial description of, a very simplified description of how the whole data pipeline actually works for us. There are many, many elements, but the 3 key elements that we have are a ETL-like data load, which happens in real time. So you have some of the similar characteristics in terms of transforms, in terms of data cleansing, in terms of relating it back to what existing data you have. You may also do projections, which we do. We also do a little bit of aggregation here, but that's not really relevant. This is the heart of the system. This is where the analytics engine actually is broken. We use the cleaned up data and the inbound data to detect events. And as I said, we take both point-in-time events. If I get a set of data that is coming in, that data may trigger a particular analytics inference tool, analytics tool engine, or a query may trigger based on that particular point. Or we may have situations where a bunch of data has to come in, or be available in the historical data for a relevant period for that tool to trigger. In either case, this till here, this is near real time. Our system processes it in less than 2 seconds. Now, just to give you a sense of what 2 seconds means, since we have Everyone has a smartphone, right? That's the closest IoT device you actually have. If you just open your web browser and click on any website, Google. Google is the most CDN website in the world. See how long does it take? Just to give you a sense of 2 seconds for 3,000 cents hard hats or 4,000 hard hats to send a 17 megabyte bulk of data and be processed in 2 seconds, which is by regulation, we have to do it in certain cases, and get the transmission of the action back. Okay, so we are doing something pretty cool here. We then have additional data pipelines which primarily look at offline data analytics, batch data analytics. We also do a lot of mashup from external data. To give you an example, a lot of our rules are not just based on the numbers that we are seeing from the sensors, but also the geo-tagging of that particular data, because the measure of that data or the meaning of the data depends on the location in certain cases. Now you may say that the location actually cannot change, right? So maps are maps, locations are locations. But there are work sites that we have where people are actually making changes to your topology. As a simple example, construction sites, work sites. The topology of that building is changing as you go along. So we need to mash up geolocation data also. So that's one example. We have other sources such as maintenance data. We can look at weather data, which is also relevant, and anything else. The other key piece which I would like to point out here is, for this particular system, especially for a safety system, knowing the event after a certain period doesn't make any sense. So in other words, the value of the data as it goes through the pipeline for an individual data point goes almost to zero at some point. There's no point knowing about it at a certain point of time if you cannot react to it. On the other hand, the aggregate data or the synthesized data that the analytics generates from that same data point increases over time. Because the more data sets you have, the more inferences you can make, the more predictive models you can apply on it, and the more accuracy you can improve on this. So there's a feedback loop. Few other points are the way this differs from, let's say, a stock market application. Because that might be a close comparison. You might say that I'm getting stock prices, and stock prices also after the sale is done or the market is closed probably doesn't have much meaning other than a historical trend. The difference here is, yes, it's similar, but here we also have a big issue, which is a core issue in IoT and IoT provided data streams, which is, number one, reliability is not guaranteed at all. There's no reliability. Your connection may be up, it may be down, it may be spotty, it may be retrying, it may have retransmitted data, so you have to clean those up. In certain cases, the data has gone stale, so you don't even want to accept that data or ingest that data if it is coming in. So data communication channels are number one issue. Number two issue is that in most sensor-based systems, you have a situation which is called an event storm. A simple example would be, all of you have seen disaster movies, I'm sure, one kind or the other, right? A classic trope in earthquake movies is that all the earthquake sensors start drilling up, and whoever is monitoring the console at that point, God knows what kind of analytics engine they are using, everything lights up, right? All the lights go red. That's an event storm. That does happen in reality. In deterministic devices, it happens here because that engine gets the hit. In non-deterministic systems, the sensors themselves get the hit. But it happens. In other words, you have a sustained volume of data that you have designed your system for, but you get into essentially a perfect storm situation where your data volume, you get deluged with the data. And you have to handle those things. Because on a real-life basis, in our case, for example, if we are getting a volume of data of that time, we have a mass disaster that we have to handle. So at that point, our concept of an incident or an event actually becomes an aggregate. So it's not that one person is getting injured, probably 10 people are getting, probably something else has happened, right? So your inference models change. So that's one crucial difference. There are other things also in terms of the kind of devices that are there. Many devices, especially as they're getting smarter and smarter, don't send you the same data schema all the time. So you cannot be guaranteed about the structure of the data. So your protocol level data formats change quite a bit. It's not that you have a fixed schema, it's not that you have a NoSQL schema, you have a known schema that varies over time based on conditions. Okay, so this is slightly different also. So just one other question. So just to summarize, some of the things which we had when we were building this system, from a pure data processing, what we found is that number one, our core need is to do real-time complex event processing on data stream. That's what we're trying to do. That's the pipeline. That's why the pipeline is there. But what we found is that our event detection logic is complex. It depends on aggregation. It depends on historical trends. It may even work in certain cases as a state machine. Based on the last event that you saw, the next event may be something else. So you move across the state machine. Because of the data connectivity issues, the data stream that we get, we are not guaranteed that the data elements come in the same time order all the time. We may, and we actually get, in some cases, older data that comes first and then we get the fresh data. And that's quite possible. Purely because of the channel issues, but that's what happens. Data schemas vary because of the configuration setup. Again, the state machine itself may in certain cases change the schema. A big use case for us, this may be specific to us, but most IoT devices do use geotagging or geolocation of some sort. So the data pivot on geolocation becomes very big for us. And some of the GIS data is not static, so I simply can't pull OpenGIS data from the US Gulf and map against it. So we have to change that. In our case, when the devices do go offline, they store data on board. So they send data whenever they reconnect. So for in certain situations, we have essentially a cluster of mini databases which are not connected to each other, not synchronized to each other. But whenever they reconnect, they push the data back and we have to resynchronize a lot of things. So that brings in actually a lot of context. These two are probably common across any system. We are facing the same things. Data mashups are required across the board in terms of EAI as well as data connectivity. A few other issues for us, because of the solution we are selling, it has to be customized for each site and each customer. For example, an oil and gas customer will not be using the same set of analytics as a steel customer. The rules are different, the environments are different, operating conditions are different, safety regulations are different. These are also industries where they don't have a very fat pipe out onto the internet. So it's not that they have a 100T connection or something like that. So we also have to think about hybrid deployments, where a certain portion of the processing and analytics happens on-premise, on-site, and a certain portion can hopefully happen off-premise or on the cloud. For us, scaling-wise, this is more a business decision. We decided that we wanted horizontal scaling when it came to scaling up for the analytics. And the last thing is, because we are a startup, this is a business model related thing. We simply don't have enough resources to spend 8 months building up a Hadoop-based, yarn-based system, experimenting on it, and then coming up with our rules. We wanted the solution first and have some technology which could support us on that. So this was more driven by our business model, as was obviously this. This is true for any industry, not just a startup. Time to market is crucial. So we wanted to have something operational as soon as possible. So with all these challenges, we were actually in 2015 looking for a solution. And the reason I brought up Hadoop and Yarn is we were actually looking at AWS. And AWS has a pretty good, they don't call it exactly Hadoop, but it's Hadoop, where you can spin up clusters, you can play with it, you can run your own MapReduce programs on it, Biglatin related and other things. They actually have enhanced it quite a bit. You can now use Juju and just one command, it brings up the entire cluster. But anyway, we were playing with it. Through a common friend, we actually got to know about HPCC. And one of the things which I say these days is HPCC probably is one of the best kept secrets in the data market. Most people don't know about them. Neither did we actually. We also didn't know about them. But we explored their solution, and what we found is, for all the things that I listed in the prior two slides, it was actually able to address almost all of them. Not 100%, but it was the closest in terms of where we wanted to. So why did that happen? The biggest reason we found is, and I strongly urge you to try it, probably take you about 15 minutes to try it and make a decision. For us, the biggest reason is HPCC is a batteries included system. It's a whole componentized, everything included system. At least for our solution, and I believe for most of the applications, it actually does a lot more than what we need. It has your ETL, it has a consistent language, it has the clustering mechanism built in, it has management built in, it has WLM built in, it can be deployed on-premise, deployed in a hybrid fashion, deployed on the cloud. They actually have quite an extensive thing running on the cloud, I think might be listed in the training programs that you have shared. They focus, the second reason was, their whole model is they focus on the solution set. They have all the technology components that you need to run something like this, but they focus on the domain. They focus on the solution domain. They have something called ECL, which is their declarative data processing language. It's a parallelized language, very similar to Pig Latin in terms of its code. Obviously, the syntax is different, but the theory is the same. But what it does is, it remains consistent end-to-end across the system. Once you know ECL, that's the only thing you need to know. You don't have to know Java for your MapReduce and Pig Latin for your data programs, and Yarn programming for your cluster management, and the TLS that come with that. So this was another big thing that we found that really attracted us, because for us, either we had to learn something on Pig Latin, or Swazzle is the other one from Google if you were doing GFS. For us, having a single language actually simplified our data modeling. The other good thing which we found is ECL being declarative, just like Pig Latin, but I think it has a higher maturity, allowed some of our analysts to actually model what they actually needed from the queries as well as from the rules and the overall event flow without knowing the underlying technology, which was a big win for us. Because we may be able to spin up a cluster and run 20 nodes with whatever we are running. But sometimes it's hard for us to know exactly what is the condition that we actually want to detect and what frames that condition. For that, having a declarative language like this, where our analysts can actually play with the data, write it with the same language that the developer is also going to use, meant a lot. Third one is the same thing. I already spoke about the flexible deployment model. The deployment model is very, very flexible. I mean, if you want to play around with this one, go hit their site. If you want to run it on your local computer, it's a single RTM. It's primarily Linux based. You do have OS X and Windows also. But literally download it, install it in 5 to 10 minutes. You have a full single node cluster with all the components up and running on your machine. Try it out. It's pretty good. What we didn't also realize is that they have been open source since 2011. So you're actually not going to put your credit card when you go and download this. They're actually open source. The source code is on GitHub. They have pre-built RPMs as well as binaries, but you can build one yourself. They actually accept commits changes as well as suggestions. We are making some enhancements with their help as a third party, but that's thanks to the open source model. And finally, this also made a lot of sense for us. We found out that this particular system has been used by LexisNexis, and I'm sure you being in the data world know who LexisNexis is. They're one of the largest data vendors in the world, if not in the country. They have been using this system since early 2000s, and they eat their own dog food. That's the model actually. They're running their data business on the same platform, and it's a multi-billion-dollar business. So viability was not an issue. And finally, given some of the other aspects of this tool, as well as this platform, it allows us to make incremental development. So rather than doing a big bang approach, we are able to, even today, we are making incremental development as you would normally do in any other sane platform. And finally, there actually is a growing community. I wouldn't say a huge community, so it's nowhere compared to Hadoop or some of the other things. But it's a very helpful community. Plus, the HPCC Systems team is very, very helpful. I mean, they have actually taken in enhancement changes from a small startup like us, and in the next version, someone was asking what is the latest and greatest. In the next version that's coming out shortly, the current version is 5.6.2, 6 is coming out shortly. They are actually going to bring in some of those enhancements that we have proposed, as have others also. So they are very open to listening to the community. In fact, I think one of the reasons we are here today is in outreach for that same reason. So again, it's open source, so keep that in mind. A few of the other things which we found that HPC does very well. This is again tied to that whole batteries included concept, but a few more details. Some examples. Data consumption endpoints are built in. You just declaratively write what you need to consume, you type to the query, you're done. And literally done, in 5 to 10 minutes you're done. It'll write the service points for you, it'll write the security endpoints for you, it'll do the WSDL, whatever else you're needing in case this is so. You can also do Kafka, you can do messaging, message connectors, things like that. A very sophisticated cluster node management along with workload management. Most of it is automatic, but you can configure it to your heart's content. But a default sane implementation would be pretty good to get started. All artifacts that you use and create are versioned. They work like a normal source code repository. So your queries, your ETL, your DI cubes, whatever you're creating in the tool are versioned exactly like, let's say, Git, or let's say a Subversion. And in certain cases, especially with ECL, what is even more unique is that whatever you create in ECL becomes new command sets that you can use as building blocks elsewhere. So you are essentially expanding the declarative language as you're going along. That's actually pretty cool if you're into it. It makes sense for a larger organization, but really enhances reusability. Machine learning and natural language processing is built in. They have very mature command sets as well as grammar to handle both situations. And if these are not to your liking, you can actually plug in additional things as well. But the out-of-the-box solutions are all pretty good. Lots of connectors to external sources. And if you don't have one, the easiest solution I found is just ask them to build you one. They probably will. I actually asked them to build a custom JDBC for a particular type that we would get. If you don't think ECL is your cup of tea, you can embed in Java, JavaScript, R, C++. By the way, ECL, the way it runs is, whatever you code and compile gets compiled into a C++ code that runs as a native program on the nodes that you're running in your cluster. So unlike, let's say, Hadoop, where your Java program is getting shunted around, you're actually running on the bare metal. So obviously, think of the performance. The WLM also allows, unlike Hadoop, multiple processors with the same program to run on a single node, and it will auto-synchronize all those things. They also have a set of IDs, both Eclipse-based as well as bespoke Windows. I think the IDs are only Windows though. So that's one thing which may or may not be a problem for you. And this is how the very, very, very high-level architecture looks like. So they have multiple components that comes as part of the package, but really two of them are important. All of the others are either metadata managers or controllers. The first one is what is called Thor. The easiest way to think about it is it's the ETL front end as well as your Hadoop grid. If you're doing Hadoop, then the first grid setup that you do, this is what it is. So it allows you to ingest a huge volume of data, do your ETL on it, and also do your basic indexing, data partitioning. In Hadoop, you partition the file sets, right, as you go along. Here also you do something similar. You partition the data sets, and that's where it happens. This is really the back side of the story. The other big component is called Roxy. Roxy is the front end side. Think of it as, it actually does a couple more things than Hadoop. One way to think about it is Hadoop plus HBase, so it makes the data persistent and queryable. So that's where the query runs. But it is also the front end for the entire system. So all your queries, all your web services, all your connectors, everything can be connected through this. They work in combination. You could run a Thorn cluster just by itself. It would be equivalent to just running a Hadoop grid. But in most cases, you do need the persistence and you need the real-time performance as well as query systems. So that's why you need proxy. ECL ties it together. As I said, ECL is the one true language, at least in their system, to do everything. So it does ETL, it does SQL, it does querying, it does BI, it does dedupe, whatever you need to do, it is a single language to do it. And again, it's declarative, so you don't tell it how to do it, you tell what you need. So again, if you have used Pig Latin or something similar, you know the model. The model is similar, the language is similar. And then obviously the data delivery happens where we need. What this slide does not show, what I wanted to highlight is, how many people here are aware of the Lambda architecture when it comes to big data? Okay, one. All right, let me explain what Lambda architecture is. When Hadoop and similar systems started, and there were others before as well, most of these systems were oriented towards the big data part of it, as in the big part of it. So you have a huge chunk of data, mass of data, maybe structured, maybe unstructured. You need a mechanism to have a very fast processing and processing on that data, on whatever you're actually processing for, whether it's a query, whether it's a report, whatever it may be. But these systems, by definition, become data set oriented. They are fixed data that you already have, that you dump on it, and then you run your process. Which is great for a lot of applications, but definitely not great for something like an IoT system. Or for that matter, any system where you have a data stream coming in, which is changing by the minute, by the second. Because these systems cannot handle variable data in that way. There are bolt-ons to make it happen, but those are not ideal. In fact, if you look at the Hadoop community, there are a couple of spin-offs that are happening. I'll talk about that. So Lambda architecture is an architecture that has come up in the recent years, which essentially says that you have three aspects to your solution. Any big data solution that complies to a Lambda architecture should have three components. The first one is the data layer or your batch layer, which is the old Hadoop. Think of it as the Hadoop, or in this case, Thor. The second part of it is what is called this delivery layer or the query layer. That's Roxy. So that is real-time performance. It gives you real-time access to the data. The third thing which you require is what is called the speed layer. Speed layer is where these two operate either in a batch mode or in a real-time mode. You should be able to do that. Thor actually does all three. So it already has two components which map one-to-one with the Lambda architecture. But what you don't see here, because it's a simplified architecture, is the speed layer is enabled by the data ingestion engines that both systems have. In fact, we as GuardHat are using one of them, where you can connect the data sources to something like Kafka and connect it as an ESB to any data source in the earth. You could use what is called superfile clusters and incrementally build up the file sets, even though they look like that. And there are a few other things which you can also do. But essentially, you can use it as a real-time system as well as a batch system. This happens to be what we are using, where, and it's really getting cut off, but essentially we have traditional batch data coming in, which works like a traditional GridFS cluster. We also have our direct live data coming in from the devices. I've simplified a lot, there's a lot of things happening. But which goes into Roxy through the other end and enables the speed layer to close the loop. So what this gives us is, I now have the ability to have data queries and analytics happen on real data that is coming in the last 2 seconds. I can also use the same system with the same language, even the same query. I don't even have to retarget it, just expand the scope if I need to look at what data came in 2 years back and do a trend analysis from there. And I'll get a very similar performance. Obviously, I'll have to design my clusters that way, but I'll get a very similar performance. Now just think about it for a minute. If you have ever done real-time data processing and also done batch, or one of them, you always know that they are don't quite go along together. This system for us allows us to do that, and that really is ultimately why we think this has been the right solution for us. Now, it can do a lot of other things as well. This is what we are using in the current version. The next version, without giving away too many things, because it has not been released, but right now it's a release candidate. You can download it, by the way, because it's open source, you can download that as well. We'll make this interface as well as general IoT data consumption much, much, much easier. to the extent that Hadoop's extensions such as Samza or Storm or Spark, I'm sure you have heard about some of those, which address the real-time side of big data handling. I may not even have to implement any of those. I currently have a Kafka system which I'll get rid of very soon once this comes up. All right. Few of the benefits which we have is because it's a declarative language, doesn't really define what I need to do. So my end solution in terms of data delivery becomes very decoupled from my analytics engine, which is always a good thing, right? Because I can design new applications based on the same data set. So that's one. The second thing which we can do is, even though we as a company started with safety, we are already looking at quite a few other things. Based on the same engine, based on the same telemetry, based on the same connectivity. And this is very, very powerful, especially if you're a startup, you need to expand your product portfolio at some point. This gives us the ability to do that. It's really awesome. I mean, we'll have to play around and see. My only suggestion is spend that time. Spend that 5 to 10 minutes, see if it makes sense. If it doesn't, it doesn't. But I think it's something worth exploring. For us, it was a revelation. Like many of you here, 2 years back, even we didn't know about HPCC, frankly. We were also like, who HPCC? But 2 years later, I think we are convinced for the right reasons. So this is it. Thank you. Let me take it, if it's okay. I actually have a short product video for GuardHat. Do you want to see that?
Yeah.
Can I just ask that right before you do the video? We are giving away a Kindle Fire HTC and a GoPuck. Did everyone have a chance to put their card in here? Raise your hand if not. I guess. So pass it around. Take it out. Pass it around. Okay. Sorry to interrupt.
The reason I wanted to show this is I spoke about the product, I spoke about the technology, but sometimes understanding a technology or a product, you need to understand the emotion behind it, not the features. Features I can enumerate, but you need to understand why that product was created. Just to give you a context, I was a CIO at one of the largest industrial complexes in the country. I could have done the same thing, and frankly, I got offers to do the same thing. The reason I chose to be a garage operated startup for the first 6 months, I didn't have top rung, so that part I didn't handle. But other than that, I was almost behaving like 23-year-old. Yes. So this feelings in this. Is the audio working?
You mean for that? It's not hooked up to the sound.
Your speaker, you can put your microphone next.
Yeah, that would probably be the best.
Can you turn on the air conditioning?
You want it off?
Useless. Know what that means? Wake up at the crack of dawn.
But frankly, for us, our mantra is if you can save one life, we have built a successful product. So that's how we operate.
All right, let's start taking questions. We're getting close on time, so let's try to get your, what do you want, Emma?
Yeah, what set do you use? What complex processors do you use?
We are currently using a dual system. So we have Esper. We are, as I said, we also are looking at Storm. We were looking at Storm, but that's probably what
Yes.
So you're saying the means of communication, one of these, for instance, SIP device. Also, people who are working on the underground, like in the mines.
Yes.
How would they communicate? How would the data get to your server?
So one of the design decisions we had right from the start is, to give you a number first, only about 40% of industrial complexes in the US have any sort of radio coverage, whether it's Wi-Fi or any other industrial grade systems also. So connectivity is a big issue, especially for industrial IoT. You have to start with the assumption you don't have connectivity and then design your system. So what we have done is, number one, the device that you saw is capable of operating in a autonomous mode. So if it's not connected, it still runs about 70% of the functionality on the device itself. So we have in fact designed our own small board computer which does the local processing if it cannot connect. If it can connect, obviously then the Lambda takes it. For low reliability data situations such as mines, actually mines are easier. Mines are easier because you have a known plan that you, especially underground mines, not open cast. You have a known plan that you lay your lines, lay your cables, you have to light things, right? You can't keep it down. So it is easier to connect data in a mine. Issue there is line of sight. Radio almost all the time works beautifully if it's line of sight. If you bring in a wall, you get what is called a multi-path. So you get echoes essentially, signal quality drops. For those things, we have a set of custom, which is our IP. We have a set of radio technologies which allows us to handle that. Not just a mine, but other situations also.
Yes.
Yes.
You do roughly about 70 megabytes of data per
Shift. 8 hours.
Okay. And you do
One
about,
second.
and it's about, you get about 100 people or more per shift.
That's an average.
Okay. You need some big iron at the back end of this. I mean, some really large storage capacity.
Yes.
What are you using for that?
So for storage, we are actually looking at a few NAS providers, SAN providers. Many of the locations where we are deploying this already have a backplane-based SAN or something similar. I'm using SAN as a generic. However, what I didn't mention, this is not unique to, this is not tied to HPCC, this is what we are doing, is, I don't know if you noticed, I mentioned the word synthesized data somewhere. I didn't say analyzed data, I said synthesized data. So in certain cases, when you are getting, let's say heart rate, I'll just take an example. Someone's heart rate is in a certain range. By the way, every person's heart rate is different, so you have a profile. But you're getting a certain set of heart rate and it is normal. It's a green day situation or a blue sky situation. Nothing is going wrong. Right? Do you need to store all the data? Or can you synthesize the trails with essentially building up mileposts and doing a data collapse? As one example. I don't know if I made myself clear. So if you have 1,000 records and every single millisecond I'm getting that data, I don't have to store 1,000 records. I can store only 10 of them because they mean the same thing. Nothing really happened. So that's another technique. There are other techniques also depending on how you do the sensors and what sensors you have. So that's why the configuration is variable. Based on which, it's almost like if you know two numbers, I can calculate the third one, so I don't store the third one. So these are some of the things we are doing. There are a few things which we have to store for regulatory reasons. A few things which we have to discard for privacy reasons. So those also come into play.
Are you using encryption and or compression?
Yes, we are using both. We are using encryption at a AES-256 level, both data in flight as well as data at rest. So essentially database as well as on the web. And compression is more for data storage for the same reasons that I talked about.
Yes.
Who are your biggest clients?
Sorry.
Who are your biggest clients?
As a startup, I can't disclose them, except let me just put them this way. They are, if you pull up the top 20 names, you'll find them.
Would you put your slides online?
Sorry?
Will you put your, are you going to make your slides available online?
It will be distributed through HPCC, so probably Eric, if you can go ahead with them.
On the meetup, you can just post a link to it in the comments.
Oh, so I'll post the link to it there.
Hi, thank you.
Sure.
That's excellent. This is going to be probably like the annoying question, but maybe it's a challenge that you get sometimes. People talking about wearing the thing on your head all the time with the sensors and the communications because people get concerned about cell phones next to your head or cell phones in your pocket. Is that?
Yes,
Yeah.
there are three major issues that come. One of them, as you very rightly said, people have, it may still be true, I mean, it has not been disproven either, right? The effects of radio being very close to tissue, body tissue. The specific term for it is called specific absorption rate, and actually FCC has a specific guideline around that. It's meant for cell phones, but we have extrapolated it for something which lasts a lot longer. You wear it all the time. You don't keep your cell phone stuff, hopefully not more than 5 minutes. So yes, we have tested against those. We have done field tests as well as regulatory tests. And in our particular design, we have had radio shielding on a certain sort, which brings it way below the levels that even FCC implements. So we have cleared that test. That is one. The second biggest issue is, which I'm surprised no one brought it up, or maybe someone will. Data privacy. It is Big Brother. Right? You have a device which is tracking you all the time. My daughter doesn't want to be tracked even though she is 8 years old and she is in the cul-de-sac. So you can imagine what happens. We have certain, which I cannot disclose again, but we have addressed that as well, both with the unions as well as with other third parties.
Do you track or you don't track? You
can't.
do, of course, you have data.
If it is required that your location needs to be known, for example, if you have an incident, the biggest thing that needs to be known is where did you have that incident? Where are you right now? Right? If I don't know where you are right now, the data is useless. Right? So in those situations, we activate it.
You again.
When you say the data privacy, right? Let's say I'm working and get a hat. If I just put it for just for the restroom, somebody I'm going because I don't know how we are tracking that this is not for me or somebody else, how we are doing that.
Okay. If you're really interested in the product, just for this group, I showed you only the product introduction, but on our site we actually have a set of 8 videos which go through some of the common cases. One of them is actually that. But to answer the question here, the hat knows if you are wearing it or not. The hat also knows if you are doing what is in the industry called reverse donning. If you see the construction workers, most of the people are wearing it wrong. They put it upside down, so the ratchet is in the front. This is more comfortable because you have higher visibility, but the hat has no value at that point. So the hat, in our case, because it has sensors, it knows whether number 1, you are wearing it. Number 2, whether you are doing reverse donning. Number 3 is who you are. Okay, so in this industry, the hats are commodity devices, right? So you may have a pool of 20 hats, 20 people come in, they just pick up one and use it. So we support that model. We also support a model which is usually in oil and gas and steel, where you are assigned a hat because your nameplate needs to be there. You need to know who you are. You don't know if you're going to get in an emergency situation, you need to know that. We support both situations, so identity also gets it. So that's why the privacy aspect becomes even more complex. But yes, the hat knows if you're not wearing it. If you go in a restroom, even though that was not your question, and I'm not selling the hat to you guys, by the way, it's a B2B sale, so it's an interesting question. We have a concept of blackout zones. There are certain areas where you may not want to be tracked. Restrooms may be one area. You may have some certain sensitive areas. We support that as well.
Yes. What would be the cost of that?
As I said, it's a B2B, so we are not selling it as a subscription model. And well, not quite subscription, but it's not exactly you pay X number of dollars I give you. It doesn't look that.
Yes.
How are you avoiding injuries per se, right? What is the hat
It's capturing a lot, and there are different configurations. But essentially, it's capturing 3 kinds of data. One is biometric, about you, the person who is wearing it. What is the state of your health? Are you doing okay? Things like that, based on certain parameters that we sense. The second thing we sense is which environment are you in. Okay, so the gas levels, temperature, set of things, which makes sense for an industry. So you need to know that industry to know what you need to sense. The third thing is we measure the context, your location, how you're moving, what's your speed. We do a lot of analysis on that as well.
But that's personal data, right? I want anyone to come.
It's not personal. The only personal data that comes into play, and which is by regulation, if you look at the HIPAA laws especially, I cannot, okay, maybe I'm giving away too much of my startup mojo here, but there are a set of data elements which are regulated by law and which come under PI. You can't call anything PI simply because it looks like a PI. Okay, your body motion, you're moving by 1.5 G is not your PI. So that's why your Apple Watch can measure you, or that's why your phone can measure you without you having to sign a disclosure. So we know what are the PI elements. For those, we have a metadata based separate system to handle them or mask them or do what is required by law.
Is it like there are any plans to do this kind of device in different areas, like in hospital or in army somewhere? No, because it's very valuable information.
Yes. Short answer is yes. Longer answer is it's not so much a technology question, it's more of a business positioning question and a market positioning. So our first play is safety and industrial safety. And part of the reason is because our backgrounds are in that. We have played roles in that, so we think we understand that as an interview. And at some point, yes, if this is successful, there is no reason why this cannot be expanded. We are actually building an ecosystem, starting with this one.
Okay, that's all the time we have today for questions, but Anupam will be here for one-on-one questions. Thank you all for coming. So, for the very first prize, the gold puck, could I ask you to just reach in, reach it around, and then pull the card out? Read it out.
Really like clear my glasses.
And roll Markland. That would be you. All right. And for the big prize, let's see. Mix it up, reach in. This is for the Kindle. And grab out a card.
Oh, that's too weird. That's my own card. That's very weird. You saw that.
I saw that. That's fine.
No. We're not doing that.
You're a Jeep?
No. Oh, it's another. It's a
coworker.
different.
Go
Someone else
figure.
from my
Same
company.
company.
Okay.
A
Excuse me,
Jeep
sorry
what?
about that.
What was it say?
Gangaram.
A Jeep Gangaram? All right, congratulations. All right. That was